At first glance, the ocean looks like one continuous body of water. But on a global map, it separates into vast, invisible zones shaped by different levels of salt. Some regions hold higher concentrations across enormous stretches of open sea. Others form broad, diluted belts across equatorial and polar waters. The surface of the ocean is not evenly mixed. It is organized into a planetary pattern that most people never notice. In this video, we follow that hidden structure across the world ocean. We move through the major salinity belts, the basin-scale distribution sectors, the broad regional surface patterns, and the global network that connects them into one marine framework. What seems uniform from a distance begins to reveal a large-scale arrangement spread across the entire planet. If this kind of calm science documentary is your style, please like the video, subscribe to the channel, and leave a comment below with the ocean topic you want to hear next. Your support helps this channel continue building long-form science videos like this one. Global ocean salinity distribution can be arranged as a planetary surface grid composed of broad concentration fields. This grid is not uniform across marine space. It appears as a patterned framework with recurring large-scale divisions. These divisions form a reference structure rather than a continuous, undifferentiated surface. Some grid sectors correspond to higher salinity fields across wide ocean areas. Other sectors correspond to lower salinity fields distributed across different parts of the global ocean. Between these larger fields, intermediate concentration areas occupy substantial portions of the marine surface. And the overall arrangement can be described through repeating salinity bands, open ocean sectors, and large reference zones. At the planetary level, salinity distribution follows a stable spatial layout when viewed as a global surface pattern. This layout can be divided into major marine reference divisions that extend across broad stretches of ocean water. Each division belongs to a larger concentration framework rather than an isolated local pattern. The full grid is defined by placement, extent, and relative concentration category. This global salinity grid is useful as a structural reference for organizing marine surface concentration fields. It supports comparison across large ocean areas without requiring local detail. It also provides a consistent way to describe salinity arrangement at the widest scale. In this form, ocean salinity appears as a distributed global framework composed of broad, ordered surface sectors. Planetary ocean salinity belts form broad horizontal zones across the marine surface. These belts are arranged at large scale and can be identified as major concentration groupings. Each belt occupies a substantial latitudinal span rather than a narrow local area. The pattern appears as a global set of distributed salinity bands. Some salinity belts are associated with relatively elevated concentration ranges across wide ocean sectors. Other belts contain more moderate surface salinity values over equally broad areas. Additional belts correspond to lower concentration ranges across major portions of the global ocean. The full arrangement is structured through multiple wide belts rather than a single continuous gradient. These planetary belts provide a simple reference framework for describing ocean salinity at global scale. Their placement supports classification of marine surface waters into large salinity categories. The divisions remain broad and generalized, with emphasis on distribution rather than local variation. Each belt functions as a major spatial unit in the overall salinity field. The ocean surface can therefore be viewed as a set of large salinity belts extending across planetary marine space. These belts organize concentration patterns into recurring global zones. Their boundaries are broad in reference use, even where the exact surface pattern is more irregular. In structural mapping terms, planetary ocean salinity belts form one of the main ways to describe the global arrangement of surface salinity. Surface salinity reference bands divide the global ocean surface into broad concentration groupings. These bands are used as spatial reference units rather than precise lines. Each band occupies a wide marine area. Together they form a large-scale framework for organizing surface salinity distribution. A reference band may correspond to relatively high salinity across extensive ocean space. Another band may represent moderate surface concentration across similarly broad areas. Additional bands may correspond to lower salinity ranges distributed over major parts of the marine surface. The pattern is arranged through grouped concentration zones rather than isolated patches. These bands support a generalized description of ocean salinity at planetary scale. They reduce the complexity of the ocean surface into broad reference categories. The structure remains focused on distribution and placement. Fine regional contrast is outside this band format. The band framework is useful for describing how salinity is arranged across global marine space without local subdivision. Each reference band marks a broad concentration field with clear mapping value. Some bands extend widely across the ocean surface. Others appear as large but more limited reference sectors. As a structural format, surface salinity reference bands provide one of the main ways to classify the planetary arrangement of marine salinity. The ocean surface can be read through these wide concentration divisions. This produces a consistent reference pattern for broad salinity organization at global scale. Marine concentration field divisions separate the global ocean surface into broad salinity categories. These divisions are used as large reference fields across marine space. They do not indicate local variation. They identify major concentration groupings at planetary scale. Each field division corresponds to a general salinity range distributed over a substantial ocean area. Some divisions contain relatively elevated concentration values across wide surface sectors. Other divisions represent moderate salinity across extensive marine regions. Additional divisions correspond to lower concentration fields that occupy broad parts of the global ocean. The result is a structured surface arrangement composed of multiple large salinity fields. These field divisions function as an organizational system for describing ocean salinity in broad spatial terms. The emphasis remains on placement, extent, and concentration category. Each field belongs to a larger global framework rather than an isolated marine sector. The reference use of these divisions is based on large-scale pattern recognition across the ocean surface. At planetary scale, marine concentration field divisions provide a practical format for mapping salinity distribution without basin-specific detail. They reduce the global surface into major salinity fields that can be compared by size and position. The ocean can then be described through a set of distributed concentration divisions. This creates a stable reference structure for broad surface salinity organization across global marine space. Latitudinal salinity sector layout organizes the ocean surface into broad east-west concentration sectors aligned by latitude. These sectors form a large-scale reference pattern across global marine space. Each sector occupies a substantial horizontal range. The full layout can be read as a set of salinity groupings distributed across major latitudinal belts. Some latitudinal sectors correspond to relatively high surface salinity across wide ocean areas. Other sectors represent moderate concentration ranges extending across broad marine zones. Additional sectors correspond to lower salinity fields over large portions of the ocean surface. The arrangement is defined by position and extent rather than local irregularity. This sector layout provides a structural format for mapping salinity distribution at planetary scale. It allows the marine surface to be divided into major concentration sectors without basin-specific detail. Each sector functions as a reference unit in the wider salinity framework. The pattern remains broad and categorical in its spatial use. Across the planet, latitudinal salinity sectors create a clear organizational layout for surface concentration fields. Some sectors extend across very large ocean spans. Others appear as more limited but still broad latitudinal regions. Taken together, these sectors form a stable reference system for describing the global arrangement of ocean salinity through horizontal spatial divisions. Open ocean salinity range regions divide the marine surface into broad concentration areas across major expanses of ocean water. These regions are defined by general salinity range rather than narrow local detail. Each region occupies a substantial part of open marine space. Together, they form a large-scale reference pattern for global surface salinity distribution. Some open ocean regions correspond to relatively elevated salinity across wide surface sectors. Other regions represent intermediate concentration ranges extending over large ocean areas. Additional regions correspond to lower salinity values across broad portions of the open sea. The arrangement is structured through grouped salinity ranges distributed across planetary marine space. These salinity range regions provide a practical format for organizing ocean surface concentration at global scale. The focus remains on spatial extent, relative category, and broad surface placement. Individual regions belong to a wider marine concentration framework. Their reference value comes from their size and position rather than regional contrast. At the widest scale, the open ocean can be described through a set of salinity range regions that recur across large marine surfaces. Some regions cover extensive areas with similar concentration levels. Others form broad but more limited sectors in the overall surface pattern. This regional format supports a stable structural view of ocean salinity as a distributed system of large open ocean concentration fields. Pacific salinity distribution sectors can be arranged as broad concentration regions across the basin surface. The pattern is not uniform across the Pacific. It is organized through large marine sectors with different salinity ranges. These sectors provide a basin-scale reference structure for surface salinity placement. Large portions of the Pacific are associated with moderate salinity values across extensive open ocean areas. Other sectors correspond to lower salinity ranges across major parts of the basin. More limited sectors contain relatively higher surface salinity, mainly in broad subtropical parts of the Pacific. The overall arrangement is distributed across wide ocean space rather than concentrated in a single sector. At basin scale, Pacific salinity placement appears more diffuse than in some other major oceans. Lower and moderate concentration regions occupy much of the surface framework. Higher salinity sectors are present, but generally cover less of the basin than comparable regions elsewhere. This produces a broad distribution pattern with substantial internal variation across large marine sectors. Pacific salinity distribution sectors are useful as a structural map of basin-scale concentration organization. They divide the basin into major reference regions based on relative salinity range and surface extent. Each sector belongs to a larger Pacific-wide arrangement rather than a local pattern. In this format, the Pacific can be described as a basin composed of wide, unevenly distributed salinity sectors across its marine surface. Atlantic salinity distribution sectors form a broad basin-scale pattern across the ocean surface. The Atlantic is commonly associated with relatively elevated salinity over large marine areas. This pattern is arranged through extensive concentration sectors rather than a uniform basin surface. The resulting structure can be mapped through major salinity regions with different spatial extent. Large parts of the Atlantic correspond to higher salinity ranges across broad open ocean sectors. Other parts of the basin contain moderate concentration fields distributed over substantial surface areas. Lower salinity sectors are also present in the Atlantic, though they occupy more limited portions of the basin-wide framework. The overall pattern is defined by placement of these major sectors across the Atlantic surface. At basin scale, the Atlantic often appears as one of the more saline major oceans in global reference mapping. Higher concentration regions cover a significant share of its open ocean area. Moderate salinity sectors occupy additional large regions across the basin. Lower salinity fields remain part of the structure, but do not dominate the full Atlantic layout. Atlantic salinity distribution sectors provide a clear reference system for basin-level concentration mapping. They organize the basin into large salinity categories based on broad surface placement and relative range. Each sector functions as part of a wider Atlantic framework, rather than an isolated local region. In structural terms, the Atlantic can be described as a basin with extensive high salinity sectors integrated with moderate and lower concentration regions across its marine surface. Indian Ocean salinity distribution sectors form a broad basin-scale arrangement across the ocean surface. The basin contains extensive marine areas with relatively elevated salinity. Other large sectors correspond to moderate concentration ranges across open ocean space. Lower salinity regions are also present as part of the wider surface pattern. The salinity structure of the Indian Ocean can be mapped through major sectors defined by relative concentration and spatial extent. Higher salinity sectors occupy substantial portions of the basin in large open water regions. Moderate salinity sectors extend across additional broad areas of the basin surface. Lower salinity sectors appear in other major parts of the basin-scale framework. At basin scale, the Indian Ocean shows a varied but organized salinity distribution. The arrangement is not evenly spread across all marine areas. Some sectors are marked by extensive higher salinity coverage, while others are identified by broader moderate concentration fields. Lower salinity regions remain part of the overall basin pattern without defining the entire ocean's surface. Indian Ocean salinity distribution sectors provide a structural format for describing basin-level salinity placement. The emphasis remains on large marine divisions rather than local detail. Each sector functions as a reference region in the wider Indian Ocean framework. In this form, the basin can be described as a set of major salinity sectors distributed across broad open ocean areas with differing concentration ranges. Southern Ocean salinity sector refers to the broad concentration pattern distributed across the ocean surrounding Antarctica. At basin scale, this sector is commonly associated with relatively lower surface salinity compared with many lower latitude ocean regions. The pattern extends across a large circumglobal marine area. It functions as a major reference sector in global salinity mapping. Much of the Southern Ocean surface falls into lower to moderate salinity categories across wide open water regions. Higher salinity areas are less extensive in this basin-scale framework. The overall arrangement is spread across a broad, ring-like marine sector rather than a compact ocean block. This gives the Southern Ocean a distinct position in large-scale salinity distribution. In structural mapping, the Southern Ocean salinity sector can be treated as a major concentration region defined by wide surface extent and relatively restrained salinity range. Its placement is continuous across a large high-latitude marine zone. Moderate salinity areas occupy additional broad sectors across the same circumglobal surface pattern. The distribution remains organized at large scale without requiring local subdivision. This salinity sector provides an important basin-level reference for comparing major oceanic distribution regions. Its surface concentration pattern differs from more saline subtropical sectors in other oceans. It remains identifiable as a large marine region with broad low to moderate salinity coverage. In this format, the Southern Ocean appears as a continuous high-latitude sector in the global arrangement of basin-scale salinity regions. Arctic salinity distribution regions form a broad basin-scale pattern across the northern polar ocean. These regions are generally associated with lower surface salinity in comparison with many with less pressure on the sky I have. The overall arrangement is distributed across a relatively enclosed high-latitude marine area. In global reference mapping, the Arctic appears as a major low-salinity basin region. Large parts of the Arctic surface correspond to low-salinity ranges across extensive marine sectors. Moderate salinity regions are also present across substantial areas of the basin. Higher salinity sectors are more limited in overall surface extent. The basin-wide pattern is therefore organized through dominant low salinity coverage combined with additional moderate and smaller higher range regions. At basin scale, Arctic salinity placement is structured through major concentration regions rather than local irregularity. The low salinity character of the basin is visible across much of its marine surface framework. Moderate concentration sectors contribute further spatial variation across the basin. The larger pattern remains clear as a distribution of broad salinity regions occupying different parts of the Arctic Ocean. Arctic salinity distribution regions provide a useful structural format for basin-level mapping. They divide the basin into major concentration categories based on relative salinity range and surface position. Each region belongs to the wider Arctic framework, rather than a localized pattern. In this form, the Arctic can be described as a basin dominated by broad, low salinity regions, with additional moderate and more limited, higher salinity sectors across its marine surface. Interbasin salinity contrast zones describe the broad differences in surface salinity among the major ocean basins. These zones are not narrow boundaries. They are large comparative sectors used to distinguish basin-scale concentration patterns across global marine space. Each contrast zone reflects the relative salinity character of one basin in relation to another. The Atlantic commonly occupies a higher salinity position in interbasin comparison across extensive surface areas. The Pacific is generally associated with lower to moderate salinity across much of its basin-scale framework. The Indian Ocean includes broad, higher and moderate salinity sectors in its overall arrangement. The Southern Ocean and Arctic are more closely associated with lower salinity ranges across large high-latitude marine regions. These interbasin contrast zones provide a structural way to map comparative salinity placement without local detail. The emphasis remains on broad differences in concentration range and regional extent across entire ocean basins. Some basins are defined by more extensive high salinity sectors. Others are characterized by dominant moderate or lower concentration coverage. At global scale, the contrast pattern among basins creates a recognizable salinity ordering across marine space. This ordering is distributed through major oceanic regions rather than isolated local fields. Each basin occupies a relative position in the wider concentration framework. In structural mapping terms, interbasin salinity contrast zones form a comparative layer that organizes the global ocean into distinct basin-scale salinity categories. Equatorial salinity bands form broad surface zones across low-latitude ocean regions near the equator. These bands are generally associated with lower to moderate salinity compared with many subtropical ocean areas. Their distribution extends across major sections of the global marine surface. In latitudinal mapping, they appear as a recognizable belt within the wider salinity band system. The equatorial band does not form a perfectly uniform strip across the planet. It appears instead as a broad zonal region with substantial marine coverage in multiple ocean basins. Lower salinity values are common across much of this latitudinal belt. Moderate salinity sectors are also present across parts of the same equatorial sail. As a structural reference, equatorial salinity bands provide a large-scale category for organizing surface concentration by latitude. Their role is based on planetary placement rather than local variation. The belt format allows ocean salinity to be grouped into wide horizontal zones across the marine surface. In this arrangement, the equatorial band occupies a distinct low-latitude position in the global salinity pattern. At planetary scale, equatorial salinity bands remain one of the main zonal components of ocean surface salinity distribution. Their concentration range and spatial extent distinguish them from adjacent latitudinal categories without requiring boundary detail. This makes the equatorial band a stable reference unit in broad salinity mapping across the world ocean. Tropical salinity fields occupy broad low-latitude ocean areas on either side of the equatorial band. These fields form extensive surface regions within the global latitudinal salinity system. Their salinity values are commonly moderate to moderately high across wide marine sectors. The overall pattern is distributed across multiple major ocean areas at tropical latitudes. These tropical fields do not appear as perfectly continuous global strips. They are better described as broad zonal regions with large surface extent and recurring concentration ranges. Some tropical salinity fields correspond to moderate values across substantial ocean space. Other parts of the tropical zone are associated with moderately elevated salinity across additional wide marine regions. The full arrangement remains structured through large horizontal fields rather than local detail. As a reference format, tropical salinity fields provide a major latitudinal category for surface salinity mapping. Their placement is defined by broad planetary position across low-latitude marine space. The field structure supports classification of the ocean surface into wide concentration regions organized by latitude. In this zonal framework, tropical salinity fields occupy a distinct position between equatorial and subtropical categories. At global scale, tropical salinity fields contribute a substantial share of the ocean's broad surface concentration layout. Their marine coverage is extensive across the world ocean. Their concentration range is generally more elevated than equatorial low salinity areas, while remaining below many subtropical maxima regions. This makes the tropical field a consistent reference unit in the wider arrangement of latitudinal ocean salinity bands. Subtropical salinity maxima zones form some of the most elevated surface concentration regions in the global ocean. These zones occupy broad marine areas at subtropical latitudes in both hemispheres. Their placement appears as large horizontal sectors across major ocean surfaces. In latitudinal salinity mapping, they represent a major concentration category with wide planetary extent. The subtropical maxima zones are associated with relatively high salinity across substantial portions of open ocean space. They do not appear as narrow lines. They are better described as broad zonal regions with extensive surface coverage and clear reference value. Some of these high salinity zones extend across very large marine sectors in the major oceans. As a structural unit, subtropical salinity maxima zones provide a central reference for identifying the upper end of broad surface salinity distribution. Their role is spatial rather than interpretive. They define major horizontal areas where surface concentration is widely elevated compared with adjacent latitudinal categories. This gives them a prominent place in the global arrangement of ocean salinity bands. At planetary scale, these zones contribute a repeated pattern across the ocean's surface in both hemispheres. Their broad marine extent makes them one of the clearest zonal features in global salinity mapping. The concentration structure of the subtropical belt is organized through large elevated salinity regions distributed across multiple ocean basins. In this format, subtropical salinity maxima zones function as major high-range bands in the worldwide surface salinity system. Mid-latitude salinity sectors occupy broad ocean regions between subtropical and higher latitude salinity bands. These sectors form a major part of the global surface salinity layout. Their concentration range is commonly moderate across wide marine areas. In latitudinal mapping, they appear as extensive zonal regions with large planetary coverage. These sectors do not form perfectly uniform bands across the world ocean. They are arranged as broad horizontal regions with recurring salinity ranges across multiple basins. Some mid-latitude sectors correspond to moderate salinity over large open ocean surfaces. Other parts of the same latitudinal category include moderately lower concentration fields across additional broad marine areas. The overall pattern remains organized by wide zonal placement rather than local variation. As a structural reference, mid-latitude salinity sectors provide a broad classification unit for marine surface concentration outside equatorial, tropical, and polar extremes. Their position is defined by latitude and spatial extent. The sector format supports a stable mapping system for horizontal salinity organization at planetary scale. Each sector belongs to the wider global arrangement of zonal surface salinity fields. At the global level, mid-latitude salinity sectors occupy a substantial share of ocean surface area. Their concentration pattern is generally less elevated than subtropical maxima regions and less reduced than many polar salinity fields. This gives them a distinct role in the global salinity band system. In structural terms, they form broad intermediate salinity sectors across the marine surface. High-latitude salinity regions occupy broad ocean areas toward the upper and lower ends of the global latitudinal framework. These regions are generally associated with lower surface salinity than many tropical and subtropical zones. Their distribution extends across large marine sectors in both hemispheres. In planetary salinity mapping, they form a major category of broad zonal placement. These regions do not appear as uniform belts across all ocean areas. They are arranged as extensive high-latitude sectors with recurring low to moderate salinity ranges. Some parts of these regions correspond to relatively low concentration across wide marine surfaces. Other parts contain moderate salinity over additional broad ocean areas. The overall structure remains organized by latitude and surface extent rather than local irregularity. As a structural reference, high-latitude salinity regions provide a broad classification unit for ocean surface concentration near polar zones. Their value lies in large-scale spatial organization. They allow marine salinity to be grouped into major horizontal regions across the upper and lower global ocean. This format supports consistent planetary mapping without local subdivision. At global scale, high-latitude salinity regions form one of the main low-range components of the ocean surface salinity system. Their concentration pattern contrasts with the more elevated sectors of lower latitudes. Their marine coverage is extensive across major northern and southern ocean areas. In this way, they function as broad high-latitude reference regions in the worldwide distribution of surface salinity. Polar surface salinity fields occupy the highest latitude marine regions of the global ocean. These fields are generally associated with lower surface salinity compared with many temperate, tropical, and subtropical ocean areas. Their spatial extent is broad across northern and southern polar waters. In global salinity mapping, they form a distinct surface concentration category. These polar fields are not arranged as perfectly uniform bands. They appear instead as large high-latitude surface regions with recurring low to moderate salinity ranges. Lower salinity values are common across substantial parts of polar marine space. Moderate salinity fields are also present across additional broad sectors of the same latitudinal category. The overall structure remains organized through wide surface fields rather than narrow local patterns. As a reference unit, polar surface salinity fields support large-scale classification of ocean salinity by latitude. Their placement at the outermost ends of the planetary marine surface gives them a clear role in the wider zonal framework. The field structure allows the highest latitude ocean surface to be grouped into a broad concentration category with stable mapping value. This category remains distinct from lower latitude salinity bands without requiring detailed boundary treatment. At planetary scale, polar surface salinity fields represent one of the main low-range components of the global surface salinity system. Their large marine extent and characteristic concentration levels make them a consistent part of broad ocean salinity mapping. In this format, they function as major polar reference fields across the world ocean surface. High salinity surface zones occupy broad marine areas where ocean surface salinity remains in the upper range of the global distribution pattern. These zones are concentrated in large open water regions rather than isolated local patches. Their spatial extent can cover substantial sections of the ocean surface. In broad salinity mapping, they form major concentration regions with clear surface placement. These zones are commonly distributed across extensive subtropical marine sectors. Their arrangement appears as wide regional fields rather than narrow linear features. Some high salinity zones extend across large parts of open ocean space with relatively continuous surface coverage. Other zones appear as broad but more limited concentration regions in the wider marine framework. As a structural category, high salinity surface zones provide a clear reference for the upper range of ocean surface concentration. Their value lies in regional placement and areal extent. The category supports global mapping by grouping major surface regions with similarly elevated salinity. This creates a practical regional pattern format without requiring basin-specific subdivision. At planetary scale, high salinity surface zones form one of the most recognizable concentration categories in ocean salinity distribution. Their surface fields are broad, stable in reference use, and widely distributed across the marine surface. Their regional pattern contrasts clearly with diluted surface zones and intermediate salinity areas. In this format, they function as major high-range regions in the global arrangement of ocean surface salinity. Moderate salinity surface zones occupy broad marine areas where ocean surface concentration falls between the higher and lower ends of the global salinity pattern. These zones cover substantial sections of the ocean surface across multiple regions. They do not appear as narrow features. They form wide concentration fields with clear regional extent. Some moderate salinity zones extend across large open ocean areas with relatively continuous surface coverage. Other zones appear as broad regional sectors, positioned between more concentrated and more diluted surface regions. Their arrangement is distributed across major marine space rather than confined to isolated areas. The overall pattern can be mapped as a set of extensive intermediate salinity fields. As a structural category, moderate salinity surface zones provide a central reference for broad regional salinity organization. Their role is based on concentration range and spatial placement across the marine surface. This category supports surface mapping by identifying major regions that do not belong to the upper or lower concentration extremes. The result is a practical regional format for broad salinity classification. At planetary scale, Moderate salinity surface zones make up a large share of the ocean's surface concentration pattern. Their regional extent is substantial across the world ocean. Their distribution contributes to the overall balance of concentrated and diluted salinity regions. In this format, they function as major intermediate range zones in the global arrangement of ocean surface salinity. Low salinity surface zones occupy broad marine areas where ocean surface salinity remains in the lower range of the global distribution pattern. These zones extend across substantial sections of the world ocean. They are arranged as wide regional fields rather than narrow local features. In large-scale mapping, they form a major category of diluted surface concentration. Some low salinity zones cover extensive high-latitude ocean regions with broad surface continuity. Other low salinity zones appear across large equatorial and adjacent marine sectors. Their placement is distributed across multiple parts of the global ocean, rather than concentrated in one continuous region. The overall pattern can be described through major surface areas with reduced salinity relative to surrounding zones. As a structural category, low salinity surface zones provide a clear reference for the lower end of ocean surface concentration. Their value lies in regional extent and relative salinity position. This category supports global mapping by grouping marine surface areas that share broadly diluted concentration ranges. The resulting pattern remains regional and comparative rather than local and detailed. Eldoria, at planetary scale, low salinity surface zones form one of the most recognizable components of the ocean salinity framework. Their broad coverage contributes to the full distribution of concentrated, moderate, and diluted surface regions across marine space. In this format, they function as major low-range zones in the global arrangement of ocean surface salinity. Transitional salinity belts occupy broad marine areas positioned between more concentrated and more diluted surface salinity zones. These belts form regional pattern categories rather than narrow boundary lines. Their spatial extent can cover substantial parts of the ocean surface. In broad salinity mapping, they function as intermediate belts across adjoining concentration regions. These belts are defined by moderate or gradually shifting surface salinity across wide marine sectors. Some transitional belts extend across large open ocean areas between high salinity and moderate salinity zones. Other belts appear between moderate salinity and low salinity regional fields. Their arrangement is distributed across major parts of the global ocean surface. The belt format emphasizes regional placement rather than sharp division. As a structural category, transitional salinity belts provide a practical reference for surface areas that do not fit strongly concentrated or strongly diluted salinity patterns. Their role is based on regional position and comparative concentration range. This supports a broad mapping system in which intermediate belts connect larger salinity regions across marine space. The result is a clear pattern format for wide transition sectors at the ocean surface. At planetary scale, transitional salinity belts contribute to the full arrangement of regional surface salinity patterns. Their marine extent is broad enough to form recognizing global reference units. Their placement helps organize the ocean surface into concentrated zones, diluted zones, and intermediate regional belts. In this format, they function as major transition categories in the global distribution of surface salinity. Semi-enclosed marine salinity sectors occupy ocean-connected water regions with partial enclosure relative to the open ocean. These sectors form a distinct surface pattern category in large-scale salinity mapping. The concentration ranges can differ from adjacent open marine areas across broad regional space. In structural terms, they appear as major comparative sectors between enclosed and open water salinity patterns. Some semi-enclosed sectors are associated with relatively elevated surface salinity across broad marine areas. Other sectors correspond to more moderate concentration ranges. Additional sectors may display lower salinity across substantial regional surfaces. The overall pattern is defined by regional concentration character and by its relation to neighboring open ocean salinity fields. This creates a set of marine sectors with clear comparative placement in the wider surface distribution system. As a structural category, semi-enclosed marine salinity sectors provide a useful reference for regional salinity organization outside the fully open ocean pattern. Their value lies in broad spatial extent and relative concentration range. The sector format supports comparison between partially enclosed marine areas and adjacent open water regions without requiring local process detail. This gives them a stable role in regional surface salinity mapping. At planetary scale, semi-enclosed marine salinity sectors contribute an additional layer to the global arrangement of surface salinity patterns. Their regional concentration character may align with high, moderate, or low salinity categories. Their distinguishing feature is the contrast between partial enclosure and open marine space. In this format, they function as broad comparative sectors in the worldwide surface salinity framework. Open basin surface salinity regions occupy large marine areas far from enclosed or semi-enclosed coastal configurations. These regions form the dominant surface pattern across the global ocean. The salinity ranges vary widely, but their defining feature is broad placement across expansive open water space. In large-scale mapping, they represent a main regional framework of ocean surface salinity. Some open basin regions correspond to relatively high surface salinity across extensive marine sectors. Other regions are associated with moderate salinity over broad ocean surfaces. Additional open basin regions contain lower salinity across major parts of the world ocean. The global pattern is arranged through these large regional fields, rather than through local isolated patches. Each region is identified by concentration range and broad surface extent. As a structural category, open basin surface salinity regions provide a reference format for the main salinity organization of the ocean surface. Their role is based on regional scale and open water distribution. This supports a broad mapping system in which large marine areas can be grouped by surface concentration without local process detail. The resulting pattern remains clear at planetary scale. Across the global ocean, open basin surface salinity regions form the largest share of the surface concentration framework. Their extent spans major portions of marine space across multiple salinity categories. Their placement creates the primary regional arrangement against which more enclosed marine sectors can be compared. In this format, they function as the central open water regions in the worldwide distribution of surface salinity. Global Salinity Network Grid refers to the full planetary arrangement of ocean surface salinity as an integrated spatial framework. This grid is composed of broad concentration regions distributed across the world ocean. It combines major salinity categories into a single global reference layout. The structure is defined by placement, extent, and alignment across marine space. Some parts of the grid correspond to high salinity sectors distributed across wide ocean areas. Other parts correspond to moderate salinity fields that occupy substantial portions of the marine surface. Additional sectors represent lower salinity across large regions of the global ocean. These concentration categories do not appear as isolated units. They form a connected network of broad surface distribution patterns. The network grid supports a planetary scale view of salinity placement across open ocean and regionally distinct marine areas. Its role is organizational rather than interpretive. Each sector belongs to a wider arrangement of aligned salinity fields across global marine space. The grid format allows large concentration regions to be grouped into one consistent reference system. At the global level, this network can be described as a distributed framework of major salinity regions linked through overall surface placement. Some regions align in broad latitudinal patterns. Others form basin-scale sectors, or large regional categories, in the same network structure. In this format, the ocean surface appears as a unified salinity grid composed of interconnected concentration fields across the planet. Cross-basin salinity alignment sectors describe broad areas where surface salinity patterns correspond across multiple ocean basins. These sectors are not confined to one basin alone. They represent large comparative placements in the global salinity framework. Their purpose is to identify how major concentration regions align across different parts of the world ocean. Some cross-basin sectors correspond to relatively high salinity across broad marine areas in more than one basin. Other sectors represent moderate concentration ranges that appear in similarly placed ocean regions across separate basins. Additional sectors correspond to lower salinity fields distributed across multiple large marine areas. The overall arrangement is based on alignment of salinity categories rather than isolated basin description. As a structural format, cross-basin salinity alignment sectors support a global view of ocean surface concentration beyond single basin mapping. Their role is based on comparative placement and repeated concentration structure across marine space. This allows salinity distribution to be organized through broad aligned sectors that connect major ocean regions into one planetary framework. The pattern remains general and spatial rather than local and detailed. At the widest scale, these alignment sectors form part of the larger global salinity network. Some sectors extend across similar latitudinal positions in multiple basins. Others reflect repeated regional concentration categories across separated marine areas. In this format, cross-basin salinity alignment sectors function as major comparative units in the worldwide organization of surface salinity distribution. Latitudinal concentration corridor layout organizes ocean surface salinity through broad horizontal corridors that extend across major portions of global marine space. These corridors function as large-scale alignment pathways for similar salinity categories. They are defined by distributed surface placement rather than narrow linear features. In the global salinity network, they provide a structured format for organizing concentration by latitude. Some concentration corridors correspond to relatively high salinity across wide subtropical ocean sectors. Other corridors represent moderate salinity distributed across large marine regions at additional latitudinal positions. Lower salinity corridors also occupy broad horizontal spans across equatorial and higher latitude parts of the world ocean. The full layout is arranged through repeated zonal concentration paths across the planetary surface. As a structural category, latitudinal concentration corridors support a global mapping system that links surface salinity regions through broad horizontal alignment. Their function is organizational and comparative. Each corridor marks a wide band of related concentration placement across multiple marine areas. This allows salinity distribution to be described through large horizontal sectors integrated into the wider global framework. At planetary scale, the corridor layout contributes to the overall salinity network by connecting major concentration categories across broad latitudinal spans. Some corridors appear more continuous across ocean space. Others are distributed through separated but similarly positioned marine regions. In this format, latitudinal concentration corridor layout functions as a major organizing layer in the worldwide arrangement of surface salinity distribution. Surface salinity field network refers to the global arrangement of broad concentration fields distributed across the ocean surface. These fields form a connected spatial system rather than a set of isolated regions. Each field occupies a substantial marine area and belongs to a wider pattern of surface salinity placement. The network structure is defined by field position, relative concentration category, and large-scale alignment. Some surface fields correspond to relatively high salinity across extensive ocean sectors. Other fields represent moderate concentration over wide marine regions. Additional fields correspond to lower salinity across major parts of the world ocean. These categories are distributed across the planetary surface as linked regional units. The resulting pattern can be mapped as a worldwide field network of broad salinity regions. As a structural format, the surface salinity field network supports a unified view of ocean salinity distribution at global scale. Its role is based on the arrangement of major concentration fields across marine space. The network connects broad surface regions into one consistent framework without requiring local detail. This allows the ocean surface to be described through an integrated pattern of large salinity fields. At the planetary level, the field network forms one of the main reference structures for the global distribution of ocean salinity. Some fields align across similar latitudes. Others occupy basin-scale or regional placements in the wider marine framework. In this format, surface salinity field network functions a connected global system of broad concentration fields across the ocean surface. Marine salinity regional matrix organizes the global ocean surface into a broad, comparative arrangement of salinity regions. This matrix is composed of major marine sectors classified by relative concentration and spatial position. It provides a structured format for viewing the world ocean as a set of distributed regional salinity units. The matrix emphasizes placement and category across planetary marine space. Some matrix sectors correspond to relatively high salinity across wide ocean areas. Other sectors represent moderate concentration over substantial marine regions. Additional sectors correspond to lower salinity across large parts of the global surface. These regional units are not isolated from one another. They form a coherent matrix of broad salinity categories distributed across the world ocean. As a structural format, the marine salinity regional matrix supports comparison among major ocean surface regions without moving into process detail. Its role is based on large-scale classification and spatial arrangement. Each region occupies a place in the wider matrix according to concentration range and marine extent. This creates an orderly framework for organizing salinity distribution across global ocean space. At planetary scale, the matrix format contributes to the full salinity network by grouping major regional fields into one integrated reference structure. Some matrix regions align across similar latitudes. Others appear as basin-scale or broader marine sectors in the overall layout. In this format, marine salinity regional matrix functions as a global arrangement of regional concentration categories across the ocean surface. Planetary salinity distribution framework refers to the full large-scale arrangement of ocean surface salinity across global marine space. This framework combines the major salinity categories, regional placements, and broad alignment patterns into one planetary reference structure. It is defined by the organization of surface concentration across the world ocean. The emphasis remains on spatial layout rather than local detail. Some parts of this framework correspond to relatively high salinity across extensive ocean sectors. Other parts correspond to moderate concentration distributed over broad marine regions. Additional parts represent lower salinity across major portions of the global ocean surface. These categories form a distributed planetary structure rather than a single continuous field. Their arrangement can be read through large reference regions, zonal alignments, and broad marine sectors. As a structural format, the planetary salinity distribution framework supports a complete global view of ocean surface salinity. Its role is to organize the marine surface into major concentration categories linked through overall spatial placement. Each category belongs to a wider planetary system of salinity distribution. This makes the framework suitable for large-scale mapping across the full ocean surface. At the widest scale, this framework functions as the overall reference structure for global salinity organization. It includes broad horizontal patterns, major regional sectors, and comparative concentration fields across marine space. In this format, the world ocean appears as a fully distributed salinity framework composed of interconnected large-scale surface regions. Across the global ocean, salinity is not arranged at random. It forms broad belts, regional sectors, basin-scale patterns, and a wider planetary framework that gives structure to the marine surface. What first appears uniform becomes, at larger scale, a distributed map of concentration across the world's oceans. If you enjoyed this exploration of global ocean salinity distribution, please like the video, subscribe to the channel, and leave a comment below with the next ocean topic you would like to hear. Thank you for spending this time with Quiet Facts.